Up to the beginning of the 90s, plastic packaging was either incinerated or landfilled. There was neither the technology nor the infrastructure to recycle used plastic sales packaging in a sound manner. In the meantime, however, more than 500,000 tonnes of used plastic packaging are recycled each year, more than 2/3 of the total quantity produced. The extent to which this conserves resources is documented by the Resources Balance, which was compiled for the first time by the Dual System in 2001. Properly separated is half recycled. This principle applies to plastics in particular. The plastics are sorted, increasingly using automatic techniques, into the fractions bottles, films, PET, expanded polystyrene, and so-called mixed plastics, generally smaller pieces of film, cups, tubs, and plastic lids. Mechanical recycling converts plastic packaging waste into new products. Expanded polystyrene is ground and, for instance, shaped into new polystyrene articles. Old plastic films are melted and blown into new films in extruders. Or, like most plastic bottles, they're processed into high-grade regranulate. Regranulates, which are produced in various qualities, can be used to manufacture drainage pipes or pallets. Sewage pipes and plant pallets are also made from plastic packaging waste. In fact, regranulates are even used to produce children's toys. For instance, the wheels of this front-end loader. Plastics can be recycled most efficiently if they're separated homogeneously. This is why optical sorting systems are being used more and more frequently. They can identify which kind of plastic the packaging is manufactured from and sort it appropriately. Several of these near-infrared separators, connected in series, are capable of separating polyethylene, polypropylene, polystyrene and PET from each other, accurately and reliably. These sorted fractions can then be used to produce secondary raw materials with a quality comparable to that of virgin plastics. Example, PET. This plastic, which is on the advance for beverage packaging, can be recycled as often as desired as long as it's properly sorted and prepared. In the separating drum, the bottles are cleaned and the metal parts removed with a magnet. Then the bottles are ground. A blower removes most of the label fragments. The polyolefins, from which the bottle tops are manufactured, are separated out using the sink-float process. Then the PET chips, wet with soda lye, are heated in this rotary kiln. In this way, any remaining impurities and dirt are removed completely. Dried and cleaned, the PET chips are transferred to the ground stock sorting unit, where each grain that doesn't correspond to the defined colour is detected by a colour scanning camera and blown out in a fraction of a second. Product is a secondary raw material that's even suitable for clear drink bottles. However, many sorting plants are still producing considerable quantities of mixed plastics. This material can also be recycled. For instance, it can be used to produce window frames, profiles for railway track edging, or particularly long-life reusable plastic pallets. Mixed plastics are prepared prior to recycling. This means that they're shredded, automatically sorted, and caked into small pellets in pelletizers. This produces a homogeneous product with clearly defined properties. Suitable for pouring and metering, it can also be feedstock recycled in industrial-scale plants. Feedstock recycling also employs different processes. What they all have in common is that they utilize the chemical properties of the plastic. In this plant, synthesis gas is first recovered from mixed plastics and then used to produce methanol. Mixed plastics can also be of great service in the production of pig iron. Injected into the blast furnace, the agglomerate reacts with the iron ore, removing the oxygen from it. Pig iron forms and can be run off. In this process, plastic replaces heavy oil on a 1-to-1 ratio, thus helping to conserve valuable resources.